All right, so this part two of the lesson dealing with more on functions and their graphs. In this lesson, we're going to talk about evaluating piecewise functions, and so the idea of piecewise may be new for some of you. What are piecewise functions, what they look like, and then we're going to graph these piecewise functions. Okay, so up until now, you've basically dealt with just equations, single equations. For example, you may have been asked to graph in the past, or you were asked to graph in the past, y equals, let's say, 2x minus 1. All right, and so when you graphed this was a straight line. And so it looks something like this. All right, so I'm going to do it on here. So using a t-table, if x is 0, I get y equals 2 times 0 minus 1, which is negative 1. And remember, to graph a line, this is linear, so to graph a line, we just need 2 points. If x is 1, I get y equals 2 times 1 minus 1. That's 2 minus 1, which is 1. And so I get something like this. I get 0, negative 1, which is here, and then 1, 1, which is here, and I get this line right here. Okay? So that's what you did in the past. So you graphed just single equations. All right, now what we're talking about now are called piecewise functions. And so piecewise functions are a combination of equations. So piecewise would be, let's say, a combination of equations. So you could have two or more equations. All right. And so when we did this from the domain here, if you look at the domain would be all real numbers. I can use any real number. Domain's all real numbers. So I could have used any real number for x and gotten a y value. All right. So if x is this value right here, whatever that value is, I get a point on the graph. So domain's any real number for that. Okay. Now with piecewise function, this is what it's going to look like. So you're going to say, now watch how it looks. So f of x equals, so some function, so we call it f of x, equals, let's say, 2x minus 1. If, and then your domain is not going to be all real numbers. So your domain, let's say, will be all the x's that are less than or equal to 1. All right. So this function is equal to 2x minus 1 if my domain, if the element in my domain is less than or equal to 1. It is equal to 3x plus 1 if the x value is greater than 1. So normally, it's not always the case though, but normally these numbers will be the same, and they cannot overlap. So if this is x is less than or equal to 1, then this would be x is greater than 1. It wouldn't be greater than or equal to 1, because then you would have two, for this x value, if x is 1, you would have two different y values, and it would be no longer a function. All right, so it would look something like this. Now again, so these values of x, these ones though, will not always be the same. This could have been 1, this could have been a 3, let's say. Okay? X is greater than 3. Okay, so that's what a piecewise function looks like. So this function is made up of two equations, two expressions, 2x minus 1, and I use 2x minus 1 if x is less than or equal to 1, and then 3x plus 1 if x is greater than 1. And you're going to see what the graph's going to look like in a little while. Okay, so that's piecewise functions. Okay, now to get started, before we graph, let's talk about how to evaluate functions. That's going to be important when we graph. Knowing which one to use for certain x's is going to be important for the graphing part. Okay, so let's suppose for this one, let's call this number 1, and let's say we want to find, let's call this 1a, and let's say we want to find f of, let's say, 0. Okay, so here I'm saying that I want to know what's the y value when x is 0. So I'm saying x is 0. So I got to use the 1. I got to use either this one or this one, but I got to use the 1 where x is less than 0. I'm sorry, x is equal to 0. So here's the question. Is 0 bigger than 1? The answer is no. Is 0 less than or equal to 1? The answer is yes. So 0's in here. Okay, 0's in here. So 0 is less than or equal to 1. So I'm going to have to use this function here, 2x minus 1. So f of 0 is going to equal 2 times 0 minus 1. So 2 times 0 is 0. 0 minus 1 equals negative 1. So that's what f of 0 equals. So f of 0 equals, in the blank, you'd put negative 1. Okay, so you got to determine for that value of x, for whatever x is, you got to determine which one of these it falls into. Is it in this one or is it in this one? All right, B, suppose you want to find f of 2. All right, well, is it going to be this one? Is 2 less than or equal to 1 or is 2 bigger than 1? Because this is your x value, remember, this is your x. So is 2 less than or equal to 1 or is 2 bigger than 1? Well, 2 is bigger than 1, so now I'm going to use this part of my function. So I'm going to get 3 times 2 plus 1. So that's 6 plus 1, which is 7. So f of 2 equals 7. Okay? Let's do f of 1. So let's do C. Find f of 1. Well, I got to determine which one of these I'm going to need. So the question is this. Let's look at this one. Is 1 bigger than 1? The answer is no. 1's not bigger than 1. All right, well, let's look at this one. Is 1 less than or equal to 1? The answer is yes. 1 is equal to 1. So that's this one you're going to use. So I'm going to use this function. So I'm going to say 2 times x, x is 1, where this is your x, minus 1. So that's 2 minus 1, which is 1. So f of 1 equals 1. Okay? All right, now, when we graph these, keep in mind this. So you're saying when x is 0, my y value is negative 1. When x is 2, my y value equals 7. When x is 1, my y value equals 1. That's going to be important. That's what that means. Okay? So when x equals 0, y equals negative 1. When x equals 2, y equals 7. When x equals 1, y equals 1. That's what you found. That's what all this means. Okay? All right, let's look at number 2. This part's not that difficult. It's fairly easy. Okay, so let's look at this one. So let's say number 2 that my piecewise function. Remember, these are piecewise functions. So notice they're listed as 2 or more equations. So let's say my function f of x is going to equal 6x minus 1 if x is less than 0, and then 7x plus 3 if x is greater than or equal to 0. Okay? All right, so let's part A. Let's find f of negative 3. All right, so the question is this. When x is negative 3, which of these do I use? Is negative 3 less than 0, or is negative 3 greater than or equal to 0? Well, negative 3 is less than 0, so I have to use this one. So I'm going to say equals 6 times x. X is negative 3 minus 1. And so I get negative 18 minus 1, which is a negative 19. So f of negative 3 equals a negative 19. So again, what I found was if I were to graph this, if I were to plot that point, the ordered pair would be, well, when x is negative 3, y is negative 19. So what this means, so when x is negative 3, y equals negative 19. So the ordered pair would be negative 3 comma negative 19. All right. But on the blank, if that's all you had was f of negative 3, you just put negative 19. But this is what this means. It means this. All right. B, let's suppose you want to find f of, let's say, 0. Find f of 0. Okay, so remember, you got to determine which one of these 0 falls into. Is 0 in this part of the domain or 0 in this part of the domain? So, is 0 less than 0? The answer is no. 0 is not less than 0. Is 0 bigger than or equal to 0? Yes. 0 equals 0. So I'm going to use this function here. So I'm going to say 7 times x, remember this is x is 0, plus 3. 7 times 0 is 0, 0 plus 3 equals 3. So f of 0 equals 3. Okay? C, find f of 4. Well, again, you got to determine which one of these 4 falls into. Is 4 less than 0? The answer is no. Is 4 bigger than or equal to 0? The answer is yes. I'm going to use 7x plus 3. So you get 7 times x. Remember, x is 4 plus 3. So that's 28 plus 3, which is 31. So f of 4 equals, in the blank, you put 31. All right, let's look at this one. So let's say you wanted to, you're given that g of x equals, and then this piecewise function is x plus 3 if x is greater than or equal to negative 3, and then the opposite of x plus 3 if x is less than negative 3. All right, and let's say you want to find f of 0. All right, find f of 0. All right, so I got to determine which one 0 falls into. Is 0 bigger than a negative 3? The answer is yes. So I have to use this one. So I'm going to use x plus 3. So it'll be 0, because that's x. So 0 plus 3, which is just 3. So f of 0 equals 3. B, find f of negative 6. Alright, so I can determine which one's negative 6 falls into. Is negative 6 bigger than or equal to negative 3? The answer is no. Is negative 6 less than negative 3? The answer is yes. So I'm going to use this one. But remember, it's the opposite of x plus 3, where x plus 3 is in parentheses. So it's got to look like this. Opposite of x. X is negative 6 plus 3. And so negative 6 plus 3 is a negative 3. So I have the opposite of negative 3, which equals a positive 3. So the opposite of negative 3 is a positive 3. So f of negative 6 equals 3. All right, and then finally C. Suppose you want to find f of negative 3. Well, I've got to determine which one to use. Is negative 3 bigger than or equal to negative 3? The answer is yes. I'm going to use this one. So I'm going to use x plus 3. So f of negative 3 is going to equal x, which is negative 3 plus 3, and that's 0. So f of negative 3 equals 0. All right, and then let's look at one more. So there's number 4. So we have h of x is going to be this piecewise function, x squared minus 9, if x does not equal 3, and then, oops, sorry, x squared minus 9 over x minus 3. So that's what that function is, if x does not equal 3, and then 6 if x equals 3. Okay? All right, so let's think about this one, but what you're going to see. All right, A. So we're going to find each of these. So A, let's suppose you want to find h of 5. All right, so now notice that in the previous ones, you were actually listed as inequalities, less than, greater than, equal to, greater than, equal to, less than, things like that. Okay? Here, it's listed as not equal to and then equal to. All right, so let's see how that works. So here's the question. You want to find the y value when x is 5. All right, so here's the question. Let's look at this one. Is 5 equal to 3? The answer is no. So I can't use this one. Look at this one. Is 5 not equal to 3? Listen to the words. Is 5 not equal to 3? The answer is yes. 5 does not equal 3, so I have to use this one. All right, so I'm going to say bx squared. Remember, x is 5, so I say 5 squared minus 9 divided by x, which is 5, minus 3. So that's 25 minus 9 over 2. So that is 16 over 2, which is 8. So h of 5 equals 8. Okay? All right, B, suppose you want to find h of 0. Okay, so again, same idea. Does 0, let's look at the second one. Does 0 equal 3? The answer is no, so I cannot use this one. Is 0 not equal to 3? The answer is yes. 0 does not equal 3, so I have to use this one. All right, so h of 0 is going to be 0 squared minus 9 over 0 minus 3. 0 squared is 0, so 0 minus 9 over, and then 0 minus 3 is negative 3, so that's negative 9 over negative 3, which is just 3, positive 3. So h of 0 equals 3. All right, C, let's find h of 3. All right, now, remember this time x is 3, so here's the question, which one do I use? All right, so x equals 3. you got to see that you're going to use the second one because 3 equals 3. You're not going to use the first one because remember x is 3. So this is 3 not equal to 3? That's a false statement. 3 is not equal to 3 is a false statement. 3 equals 3 is a true statement. So I'm going to use this one. But look, there's no variable there. See, there's no variable, so there's nothing to plug into. You're not going to plug 3 into any variable because there's none. Now, if that was a 6x, if that was a 6x, you'd say 6 times 3, and that'll be 18. But there's no x there. It's just a constant. So you're told that y must always equal 6 if this is the one you use when x is 3. All right, so h of 3 is equal to 6, and that's it. That's all you can do. There was nothing to substitute in for x. All right, so there's your answer. H of 3 equals 6. Now, I want you to notice this, that no matter what number you use for x, you're always going to use the top one. See, if you want to say, let's say, find h of negative 2, see, you're only going to use the bottom one here when x is 3, and that's this one here. So if x is 3, you got to say it's 6. Everything else is going to be the top one because that's the one that makes this statement true. So for example, h of negative 2, let's say, is negative 2 not equal to 3? That's a true statement. Negative 2 is not equal to 3. So I'm going to use the top one. So that's going to be negative 2 squared minus 9 over negative 2 minus 3. Negative 2 squared is 4. 4 minus 9 over, and that's negative 5. So that's negative 5 over negative 5, which is 1. So h of negative 2 is equal to 1. Okay? All right, so that was evaluating. So that's the evaluating part for this. So that takes care of that. So it's just a matter of you plugging the value of x into the correct function. But you got to determine which one's the correct function by looking at your domain. All right, so determine which of these fits. Okay, now what we're going to do next is we're going to graph these piecewise functions. Okay, we're going to graph these piecewise functions. So let's look at this one. So let's graph these. So let's graph piecewise functions. All right, so number 1. Okay, so let's suppose you want to graph this. Let's suppose my first one is this. So f of x equal a negative x if x is less than 0, and a positive x if x is greater than or equal to 0. Okay? All right. So what you need to do first is to graph these individually, do each one individually. I'm sorry, to graph this piecewise function, do each one individually, making note of your domain. Okay? So let's graph this one first. We're going to say first, let's graph. And I'm going to use, well, let's just say f of x. I'm going to use y. Let's call this y. So first, let's graph y equals negative x. All right, I'm going to use the t-table. Use the t-table to help you. Okay, and remember your domain, you got to use, in this t-table, I got to use numbers that are less than 0. Okay, now I want you to do this. See how these are zeros here? In both of these. So first you're going to graph this, and then you're going to graph the second one, y equals x, y equals x. And then you're going to use this one if when x is greater than or equal to 0. But notice in both of these, when you use a t-table, you're going to use zeros in both. Okay, so you're going to use 0 in both. Whatever number that is the number you're going to put in both. Okay? All right, so if x is 0, let's look at this one. If x is 0, you're saying y is the opposite of 0, which is just 0. So when x is 0, y is 0. All right, now give me another number that's, now keep in mind that these are linear, functions. So these are going to be lines. Now, they're not going to be strictly lines with 2 arrows because you're going to see y in a little while, but the idea in the past that these were lines and all you needed were 2 points. Okay, so that's all you really need. But again, you must start with this number. You have to start with this. If you don't, your graph may, if you're not very careful with it, your graph may not be correct. Okay? So you must start with this. with that number that's listed here. So if x is 0, I get 0. Give me another number that's less than 0. Well, let's say negative 2. All right, so when x is negative 2, this says y equals the opposite of a negative 2, which is a positive 2. All right, so I'm going to plot the point. Now look at what's happening now. Listen to this, and you'll see what these piecewise function looks like. So number 1, this is the one that says f of x equal negative x if x is less than 0, and positive x if x is greater than or equal to 0. Alright, so when I plot the point 0, 0, and that's going to be important. When I plot the point 0, 0, don't put a dot there. Don't put a closed circle, because remember, it's strictly less than. There's no equal sign. So right now I'm going to put an open circle, just like this. So that's the origin. Put an open circle. And then negative 2, negative 2, 2 is here. And all you do now, it's not a line. Don't connect, don't draw a line through these 2 points, okay? Because remember, that first one says this. I can only use this, I can only graph this if x is less than 0. So I can't use any number bigger than 0. So basically, you're going to start here, and you're going to draw like this and draw an arrow, okay? Because I can use any number less than x. You see this arrow? So here's the open circle. Draw the line, the ray. These will be rays. Draw the ray going through it with an arrow, because this says I got to use x is less than 0. So your graph's going to go like this. Okay, it's going to be on this side. All right, let's get the other one. So over here, if x is 0, this says y equals x, which is 0. So I get 0, 0 again. Again, I need, this is linear, I just need one more point. So give me another number that's bigger than 0. So let's say 2. If x is 2, I get y equal x. Remember, x is 2. I get 2, 2. So now notice, this is not always going to happen, but it did happen here. It turns out that 0, the origin, 0, 0, was in both of these. This one's open, this one's closed. So when I graph it, I'm actually going to close it up. Alright, so you look like that. You're just going to close that open circle up because it was in here as well. And then I plot the other point 2, 2. And then I draw a ray starting here, and then drawing your arrow like that. So there's your graph. Okay? So notice this graph is made up of 2 pieces. This part and this part. That's where that came from. These 2 pieces came from here. This function and this function. Alright, let's look at another one. So this would be number 2. Let's suppose you had f of x is equal to 2x if x is less than equal to 0, and 2 if x is greater than 0. Alright? So again, we're going to graph each one individually. So make sure you actually do this. Do this piece right here. So let's first graph y equal 2x. And then we're going to graph y equal 2. Now we're going to graph y equals 2x if x is less than or equal to 0. And we're going to graph y equals 2 if x is greater than 0. Alright, so this goes with this goes with this. And then just use a t-table. Remember, these are linear, so all I need are 2 points. So give me a number less than, also remember that I got to use these numbers here. So these numbers are zeros, so I must use them in both cases. I must use them in both cases. Alright, so if x is 0, I get y equals 2 times 0, which is 0. So I get the origin. Now give me another number that's less than or equal to 0. So I already used 0, so I got to use a number less than that. So let's say negative 2 again. If x is negative 2, I get y equals 2 times x. X is negative 2, so that's a negative 4. Alright, so I found 2 points. I just plot those points. So 0, 0 is the origin. Now you see how this was closed? I'm sorry, this was an equal sign. Since that's an equal sign, this will be a closed dot, or closed circle. Okay? So 0, 0 is the origin. So that would look like this. And then I'm going to plot the other point. The other point's negative 2, negative 4. So negative 2, negative 4 is here. And all you do is just connect them. Now be careful. Don't draw a line going through them with the arrows, okay? Because remember, you got to start here. So you're looking at x is less than or equal to 0. So that's this side here. So you got to start here and go through this. Okay, so it's important that you see this. So start here and then connect them with an arrow. Okay? All right, the next one. Next piece here. All right, now listen carefully. This says y equals 2. Notice there's no variable. So from last semester or semester before that, you got to remember what y equals 2 looks like. All right, so if x is 0, listen to this. If x is 0, wherever you see the variable x, you plug in 0. But there is no x, so that means that y is going to have to equal 2. All right, now give me another number that's greater than 0. So let's say x is 3. If x is 3, this says y. Now remember, where we see an x, you plug in 3, but there's no x, so that says y must equal 2. So remember last semester, this says y equals 2. Y equals 2 is a horizontal line. So these y values are always going to be the same. Okay? All right, now let's graph the point. Now remember this, there's no equal sign here, so this is going to be open. So this one's closed, this one's open. When x is 0, it's closed here. When x is 0, it's open here because there was no equal sign. Okay, that's important. All right, so 0, 2 is here with an open circle. See how it looks? And then I'd use the other point 3, 2, which is here. And I connect them, and notice it's a horizontal line. Well, a ray. All right, so it just looks like this. So there's your piecewise function. So this ray represents, let me go ahead and draw write the function again. That was 2x if x is less than or equal to 0, and then 2 if x is greater than 0. So this piece here represents the top function, and this piece here represents the bottom function. Okay, and so notice when x is less than 0, I get this graph, and then when x is greater than 0, I get this graph with that open circle. Open circle because there was no equal sign, closed circle because there was an equal sign. Okay, so that's number 2. All right, number 3. Let's suppose you had this. All right, suppose you had f of x is going to equal x plus 3 if x is less than -2, and then x minus 3 if x is greater than or equal to -2. Oops, sorry, right here. So f of x equals x plus 3 if x is less than or equal to -2, and then x minus 3 if x is greater than or equal to -2. All right, so remember, you're going to graph each one individually. So you're going to graph y equals x plus 3. Now remember, y equals x plus 3 is linear, so it's a line with 2 arrows from last semester. But remember, your domain's restricted. So you can only graph the part that's less than or equal to -2, so keep that in mind. So x is less than -2. And then I'm going to graph the next one after this one. So I'm going to graph y equals x minus 3, but I'm going to use the domain that is bigger than or equal to -2. So in a t-table, use a t-table. Remember, these are linear, so you just need 2 points. Okay, and again, you must use these numbers in both cases. In both cases, you must use those numbers. So -2, -2. Okay? Now keep in mind, see how there's no equal sign here? So at -2, whenever you plot that point, this is going to be an open circle. Over here, see how there is an equal sign? Then this is going to be closed. Okay? Because of the equal sign. Alright? So it'll be closed because of the equal sign. Alright. So let's do this one first. So when x is -2, I'm going to say y equals x, which is -2, plus 3, which is 1. So I get the point -2, 1. Remember, all you need are one more point. So give me another number that's less than -2. So let's say -4. So if x is -4, I get y equals x, which is -4, plus 3, and that equals -1. All right, and so I'm going to plot these 2 points, keeping in mind that this is open, okay, because there is no equal sign. So I'm going to get -2, 1, which is here, open circle, like this, and then -4, -1, which is here, so that's closed. All right, and then I connect them. All right, so remember um, that part of the domain says that x is less than -2, so you got to go this way. Start here. This is where you start, and you just connect the dots with array. Looks like this. So this piece of the function represents this part of the graph. All right, and let's look at this one. All right, so I got to pick numbers that are bigger than -2. I got to use -2, just like I had to use -2 here. So in this case, this says y equals x minus 3. So when x is -2, you get y equals -2 minus 3, which is a -5. All right, now give me another number that's greater than or equal to -2. Let's say 0. If x is 0, I get y equals x minus 3. So that's 0 minus 3, which is a -3. All right, so let's see what we get. We get -2, -5, -2, -5. So that is here, closed circle. Okay, that one's closed. So remember, this one's open, this will be closed. And the other point was 0, -3, which is here. And then I connect the dots. So remember there, you're going from -2 to infinity. So you gotta start here. Remember, you must draw a ray. Don't draw a line going through this. That's incorrect. Okay, because that part of the domain is very important. You see this. When I rewrite this, it is very important you see what I'm talking about. And the next -3 if x is greater than or equal to -2. So here, you're only graphing the part that's less than -2. So here's -2, less than that, so this is the one you're graphing. Over here, you're graphing the part that's bigger than or equal to -2. So here's -2, you're going to graph the part on this side. This is where you start, and you go to the right. This is where you start, you go to the left. This is where you start, you go to the right. Okay? All right. Then let's look at number 4. So number 4, let's suppose you had, let's see, all right, let's suppose you had this. You had f of x equals 3 if x is less than or equal to -1, and -3 if x is greater than -1. Okay? All right, so we're going to graph, no, that's f of x. So we're going to graph y equals 3 first, and I'm going to graph this when x is less than or equal to -1. Keep that in mind. And then we're going to graph y equals -3, and we graph that if x is greater than or equal to -1. All right, so when I do a t-table, remember that says y always equals 3, that says y always equals -3. So when I do a t-table, again, I got to use, in both cases, I have to use this first, so -1. So make sure you use these numbers first. So that's where you're going to start. That's where you start. So when x is -1, that means I go to my function here, and where we see the variable x, I plug in -1. But remember, there is no x. So that says y must always equal 3. So when x is -1, y is 3. All right, now give me another number that's less than or equal to -1. So let's say -3. So again, when x is -3, this says y must always equal 3. All right, so no matter where you are in your y column, it will always be a 3. All right, so then I'm going to plot that. I'm going to graph that part of the function. This is number 4. And this is my function. Is equal to 3 or -3 if x is less than or equal to -1. And here if x is greater than -1. All right, so -1, 3 is, oh, and by the way, this is going to be closed because of the equal sign. Just forgot to tell you about that. So that's closed, and this will be, since there's no, oops, this is strictly greater than. Let me make sure I wrote this correctly. Yeah, so this is strictly greater than. So see how I had to be careful. All right, so that's going to be open. because there's no equal sign. All right, so -1, 3 is here, closed circle. And then I'm going to plot the point -3, 3, which is here. All right, and so notice, remember we said y, this says y always equals 3. So notice when I graph the ray, remember you're going to go to left now. Start here and then connect the dots. So you're going to get this. Oops. All right, you can get that right here. So y always equals 3. That's what that says. Okay, closed circle. All right, let's do the other part now. So this says y always equals -3. So when x is -1, where we see the variable x, I plug in -1, but there is no variable x to plug into. So this says y must always equal -3. So if x is -1, y is -3. All right, give me another number that's bigger than -1. So let's say 0. If x is 0, there's no x to plug in 0 into. This says that y must always equal -3. So in fact, no matter what number you use for x, as long as it's in this domain, you get -3. That's what that means. Just like this, you get 3 all the time. But all you need are 2 points. So if x is -1, y is -3, this is going to be an open circle. So -1, -1, -3, open circle. See how it looks? Open circle. And then 0, -3, close just the dots here. And then you connect them. So we start here and then go to your right with an arrow. You're drawing a ray. Right, so that's your 2 pieces. So this piece is the first part, and this piece is the second part. So hence piecewise functions. Okay? Alright, so that's going to take care of this part. So that's all you do there. It's not that difficult. So in this lesson, remember, you learned how to evaluate functions. And then you also learned how to graph. And these, notice that when we graph these are all rays. So these were linear functions with restricted domains, though. So you didn't draw an arrow going through like this. Some people make a mistake and do that. So it's not 2 lines, guys. It's a ray going to the left and a ray going to the right. Okay, so you got to look at your domain. So all these domains are restricted. It's not all real numbers. All right. So again, if x is less than -2, so don't draw a line. Don't draw a line with 2 arrows like that. This says you're going to start with -2 right here, and you go to the left. So you got to find out. We found out that when x is -2, -2 plus 3 is 1. So that's where you got that open circle, because there was no equal sign. It was said it was strictly less than -2. And then connect the dots, and you have your ray. All right. Okay. So that was part 2.